come back. Oh, that was loud. Oh, that was loud too. Oh. What a beautiful day it looks like out there. It's going to be really windy afternoon. Do you have a game? Does wind matter? It's probably going to be really windy. Yeah, it will be. Hey, here's your weather hint. Okay, since it's my moral obligation to teach you how to know what's going on in the weather. In the springtime, if you ever look and you see like today is going to be around 70, but tomorrow is going to be around 45. If you ever see weather like that, that means wind. You can't have a hot day and a cold day back to back if you don't have winds first. So today, the wind will blow hard from the south the later we go in the day. And then tomorrow, the wind will blow from the north. It'll switch completely. And that's because the air is being sucked into the low pressure, which goes this direction. But once the low pressure is now below us, the wind will now be sucked still into the low pressure, but it'll be going that direction. Got it? All right. So, if you don't like wind, you won't like tonight. The closer the front gets, the stronger the winds are. What's that? Not here. Yeah, that's some pretty solid winds. We're screwed in like a year. Oh, this has been recording the whole time. Well, this is awkward, isn't it? HCl, is that a weak acid? No. Is NaOH a weak anything? No, they're both strong. Okay? In order to have a buffer, you have to have a weak acid or base, and you have to have a conjugate base or acid. So this is just strong and strong. So it's a titration question. It doesn't say titration, it just says mixing. But fine, it really doesn't matter. So you find the moles. 1 times 0.1 is 0.1 mole of H plus. 2 times 0.06 is 0.12 mole OH minus. So you look, and the difference now, the excess would be 0.02 of OH minus, right? Okay, now that's the moles, but we need concentration if we're going to find pH, right? So you take the moles and divide it by the total volume, which is 1 liter plus 2 liters. That's 3. That's gross. Okay, so is this 0.00666? And what would you do with that number? Good. You negative log that, mother. Okay. But we have to subtract from 14. Did you just, oh my gosh, me? I think you did. No names. Emily Benson. All right. So we negative log this, and what did we end up with? One? All right. Now that's not my answer, right? My answer, since this was base that was excess, it's 14 minus 2.18. So we get 11.82. Oh, come on, box. Okay, well, that was fun. Can we just... So, to have a buffer, once again, just for the recording, you have to have a weak acid or base, and its conjugate base or acid. Now, the tricky part is sometimes I just give it to you. I tell you, like it's HF, and you're like, okay, HF is a weak acid, it's in my problem, that's good. Sometimes the HF comes from a chemical reaction, from the things I put into the solution. And that's what number 2 is. I'm not giving you HF, but HF will be formed because this breaks apart, and then the H and the F combine. Okay? So try number 2 on your own. Number 3 is going to be similar to number 2 probably. Okay, number 2, what is the pH made by mixing HCl with NaF? So we have F minus and we have H plus. So that's a good sign that this might be a buffer. We have to do the math first, right? So we are going to have, so it's just 1 times 0.1. So you have 0.11 moles of H plus, and then 3 times 0.08, so that's just 0.24, right? 0.24 moles of F minus. Now, based on this, we will have a buffer because the only requirements, what in the world? Okay, can't change colors today, I guess. I have to have some excess F minus, and so since this number is bigger, I will be good to go. Okay, so the amount of acid will be equal to the smaller value. So you have 0.11 moles of acid. And then the amount of base is equal to the difference, which is 0.13 moles of base, right? That's convenient because 1113 is my favorite combination of numbers. All right. Now, yeah, bruh. Thank you. You're all welcome. So which one of these do I use? HF, good. Times 10 to the negative 4, plus the log of B, which is 0.13 over A, which is 0.11. And what do we end up with? 3.8, 3.81, 3 great. Okay, we all right with that? Uh-oh, Griesbach, that was a no. What's wrong? Do you have it? Isaac doesn't want it, but everyone else? Oh.
I was driving out of Ellie Ernest's house, and there was a bunny on like this long road, and I hit it with my car, and I know I killed it.
Go look at it.
No,
what
I
is
didn't.
suffering?
She just sent it. Okay, here I have a strong acid. This will produce the conjugate base of a weak acid, right? So this could be a lot like this problem. We got to check the math, though. 1 times 0.2, so that's 0.2 of H plus, right? 2 times 0.1 is 0.2 of Cn minus. Ooh. What do we do if the numbers are equal? 0.2 moles of HCN. It's not neutral. They're equal. All right. So what do you do? Is number 3 a buffer? No. It's just a weak acid. No. It's okay. Thanks for guessing. That's when you have strong acids. Weak, it goes back, and it's interesting, things we learned first have just disappeared. But to find it, we use Ka equals x squared over initial. And remember, x, I take the let me just do this. I take the negative log of x, and that tells me my pH. When we have a weak acid, we have to use this. So the Ka, I made it up. We have 2.15 times 10 to the negative 6 equals x squared. And my initial is just this amount of stuff I made. I'll scroll up. Sorry, Emily. Is that better? Okay, now the initial is the amount I made, which was 0.2. So just take the square root of both sides. And you had to multiply it by 0.2. I didn't leave much room there either. Bless you, child. So multiply by 0.2, and then take the square root of that, and that will give you x. Does anyone have just that number? Whoa. -3? 4. I just went to get my hand out of my pocket, and I hooked that, and it flew up and hooked on my ear. It was cute. All right. Now, is this your answer? No, you negative log that mother. And you end up with 3.18. Ooh. Wow. That is. Okay. Answer your question, Brindley. A buffer consists of a weak acid and a conjugate base, or a weak base and a conjugate acid. You have to have both. If you don't have both, you're host. If you only have a weak acid, you do the x squared over initial. If you only have conjugate base, then it was complicated. We did one yesterday that way. You find the Kb, and you go from there, and then subtract it from 14. There's not one on the test like that. The previous problems, you with me? The previous problems, I gave you a strong acid, and I gave you the conjugate base, the F minus. Then, the strong acid reacts with that to produce the weak acid and the conjugate. So that's why we cancel stuff out. Like, that's why we have to do math before we Henderson-Hasselbalch. But come over here. This one gave you the amount of acid already. Acetic acid is a weak acid. So it already just gave you straight up moles. It gave it to you. And then it also gave you, like you had to do the math, but it also gave you the moles of the acetate. So this problem, yes, it's a buffer because it gave you weak acid and conjugate base. So yes, it is. We don't have to do any chemistry. All right? We just have to Henderson-Hasselbalch. We only do chemistry and then the subtracting and adding. If I gave you strong and it made a weak. This I gave you weak and I gave it to you. Did that help at all? Kind of.
This one was easier.
Yeah, this one should be the easiest of all of them we've done today, except for maybe the first one. Okay, we'll test Friday. Try these two, find the recording, and try them tonight at home.